destructive interference. So just like your constructive interference, for destructive interference, we'll use the same equation for the intensity. Now, for in case of intensity, this I1 term is a constant, I2 term is a constant, root over I1 term is constant, root over I2 term is constant. The only thing varying is cos phi. So cos phi can take all the values, can all the take the values from plus 1. Okay, see, it can take the values from plus 1 to minus 1. Fine. So the cos x values ranges from plus 1 to minus 1. And since we need a destructive interference, in order to achieve destructive interference, therefore, my cos phi term, okay, this term should be positive or negative. This should be negative. This should be minus 1. If cos phi is minus 1, then this term will be, sorry, if cos phi is minus 1, that means it is the smallest value of cos phi, then this interference term will also be the smallest. That means it will result to a minimum intensity, and this minimum intensity is known as your minima, which is your destructive interference. So look here, cos pi will be negative for which values? This is your cos wave. Now look here, for cos of pi it will be minus 1, cos of 3 pi minus 1, cos of 5 pi minus 1, cos of 7 pi minus 1, cos of 9 pi minus 1, cos of 11 pi minus 1, cos of 13 pi minus 1, and so on. So from here, look at these values. So when is cos negative? The cos is negative when its angle is multiple of a pi. Pi. Can you see? Pi, 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 pi here also. Apart from being a multiple of pi, what kind of multiple? Will it be an even multiple or an odd multiple? Look here. Is it an even multiple or odd multiple? Odd multiple. Even multiple or odd multiple? Odd multiple. Even multiple or odd multiple? Odd. Similarly, odd multiple, odd multiple, odd multiple, and odd multiple. So cos of odd multiple of pi will result into minus 1 value. When see, it will be a odd multiple. Now again, how to write the odd multiple? Suppose first write down n. Okay, first you write down n. Now to make it a odd multiple, what you will do? First you make it a even multiple. So I'll multiply with 2. Fine. After multiplying with 2, I will subtract 1 from here. Fine. Therefore, even minus 1 should always give you a odd number. So this term is a odd number. Fine. So this cos phi should be the odd multiple of, sorry, this should be the odd multiple of pi. Fine. Or I can also say my phi angle should be equals to twice of n minus 1 pi, where my n equals to 1, 2, 3, and so on till twice of n minus 1 pi. Now note, why didn't I take n equals to 0? Like for the constructive case, we have considered n equals to 0. But in our destructive case, we are not considering n equals to 0. So look here. If I take n equals to 0, then what happens? So suppose let us say 2n minus 1 pi. Okay, for n equals to 0, your angle phi will be how much? It will be this 2 multiplied by 0 will be 0, and this will be minus 1 pi. Okay, this will be minus pi. And look here, what is cos of minus pi? Okay, now see, cos is an even function. Okay, this is a topic which you will study in your maths. I will just give you a brief introduction. So cos, this cosine wave are known as your even function. What do you mean by even function? Okay, even function means, suppose, let's go back to your graph. Can you see this is your cos wave? Now, if you see at this two value, let us say at this pi value, how much I'm getting? Minus 1. Similarly, at minus pi, what I'm getting? Minus 1. At 3 pi by 2, how much I'm getting? 0. So on minus 3 pi by 2 also, I should get the same value. Minus 3 pi by 2. Am I getting the same value? Yes. So this is the example of a even function. Okay. So if I have to write down your even function, you can remember it like this. Your even function. So for your even function, if you substitute the negative x value, okay, if you substitute minus x value, it should be equal to positive x value. Fine. So look here. If I substitute for cos pi is how much? Minus 1. If I substitute minus pi, cos of minus pi is also minus 1. Take one more example. Cos of 3 pi by 2 is how much? 0. Cos of 3 pi by 2 is 0. What is cos of minus 3 pi by 2? This is also 0. Okay. I'll give you an example of a function which is an odd function. Now let's take an example of an odd function. Okay. This blue wave, this represents your odd function. Okay. Now look here, why we call this odd function. Now if I substitute the value of pi by 2, how much I'm getting? 1. Can you see? This is how much? 1. Now if I substitute minus pi by 2, if I substitute minus pi by 2, what value I'm getting? Minus 1. See, the curve which is on the plus x side, this side, the curve which is on the plus x side is not same as the curve on the minus x side. So this is a odd function. Whereas for your even function, like in this case, the curve which is on the plus x side, the values which you are getting on the positive x are the same values which you'll get on the minus x. Can you see? If you look carefully, you are getting the same values here and there also. So this is an example of an even function. This is the condition for the even function. Fine. So since cos represents your even function, so what is cos of minus pi? Cos of minus pi. Use this condition, f of minus x is x. If your function is cos, if my function is cos, then cos of minus pi should be equals to cos of pi. And this cos of pi, okay. So for this, we'll get what value? We'll get minus 1. They will give the same value. And since this minus pi, okay, this minus pi represents which value? N equals to 0. And this value represents which one? N equals to 1. So if n equals to 0 equals to n equals to 1, then in that case, I don't need to consider this n equals to 0. Why? Because I have already taken this under my n equals to 1. And why is it so? Because my cos is a what kind of function? Even function. Fine. Or you can remember it like this. Whenever you write this angle, start from 1, 2, 3. Fine. Or you can consider 0 also. If you see this part, you will do in your mathematics. Okay. You will just get a small introduction. Okay. You will get a small introduction in your integration chapter. Okay, when you will be doing your integration using the limits. Okay, your definite integrals, when you have a limit f of x dx, when you need to integrate such kind of functions. Okay, that in that topic you will discuss about this even function. Fine, and you will discuss more about this even functions in your higher classes. Fine. So for now, for my current topic, okay, for now you can consider the n equals to 0 value also. Okay, it will not bring that much difference here, but for my simplicity I start from n equals to 1 2 3 and so on. Fine. Actually the n should start from 1. Okay, and why is it so? Because I have explained here. Fine. If you are having difficulty with this one, you can ask me. Fine. If you have any confusion with this even function or odd function, you don't hesitate to ask. I will re-explain it to you again. Okay. Apart from this, okay, this point, okay, this topic is not important for your this. It's not important. It's not as much relevant for your board exams. Fine. So it's better to skip such concepts for now, because this concepts you will discuss it in more details in your higher classes. Fine. So yeah, coming back, your phi should be a odd multiple of pi, where n equals to 1 2 3 and so on till twice of n minus 1 pi. Now, as we have already derived the relation for this path difference, if you remember this one, my angle phi equals to twice pi by lambda times p. Fine. Okay, if you are having difficulty to remember this formula, okay, you can also remember it like this. Suppose, consider one whole wave. Okay, consider your one whole wavelength. This is what? This is one complete wavelength, lambda. Fine. This complete wavelength corresponds to a complete cycle. Okay, if you are having a circle, okay, let us say it starts moving, it moves the angle pi, it moves angle, sorry, at here it moves the angle pi by 2, it moves the angle pi, here 3 pi by 2. Right, it rotates and it comes back to its initial position. Okay, let me just make this one, I'll just zoom in. Okay, okay, so this one corresponds to the complete cycle. Okay, suppose you have a circle, consider this is the radius. Okay, so a complete wavelength, okay, a complete wavelength means a complete revolution of this radius. Fine. Okay, look here. Okay, now look, let us, this circle starts its revolution. Fine, and it returns back to its same position. So in this case, how much angle it is moving? The total angle moved, this angle is your 360 degree. Now in your 360 movement also, if you see properly, check how much wavelength it is covering. Okay, let me start. See, it covers one complete wavelength. Can you see like this? It is covering one complete wavelength in this case. Fine. So look here, a complete revolution. Okay, a complete revolution, that means 360-degree revolution. That means 2 pi revolution corresponds to one complete wavelength. Okay, so if I have to write phi, the ratio of phi and your path difference, phi and your path difference. Okay, so in this case, how much is the total angle moved? It is 2 pi. And how much path difference it has covered in this 2 pi angle? It has covered lambda. So from here you can also write your phi, angle phi, as 2 pi by lambda multiplied by p. Fine. So can you see this relationship between your phase and your path difference? Okay, if you forget the previous one, okay, let me just show. Okay, if you like, if you cannot remember why we took this relation, okay, then you can also remember this relations like this. Fine, as long as you have the concept why we are using this relation, how we are getting this relation, then you can use this concept. Fine. So if phi equals to twice of n minus 1 pi, so I'll substitute this relation over here. So if I substitute this relation over here, I can write twice pi lambda multiplied by p equals to twice of n minus 1 multiplied by pi. Now look here, I can cancel this pi, I can cancel this pi from here. Fine. Now apart from this one, I can send this lambda to the other side and send this 2 to the denominator. Now if I do so, then I can write my path difference p equals to odd multiple of lambda by 2. Fine. Fine. So what does this mean? From here I can show that let us say, if let us consider for n equals to 1, consider the first order. Okay, n equals to 1. If n equals to 1, then my phase difference is also what? Twice of n minus 1 pi. Can you see? So substitute n equals to 1, 2 multiplied by 1 is 2, minus 1 will be 1, 1 times pi will be pi. So this one will be simply pi. Fine. What will be my path difference? Substitute the value of 1. So I will get 2 ones are 2, minus 1 will be 1, 1 times lambda by 2 will be lambda by 2. So my path difference will be simply lambda by 2. So when my phase difference is how much? Pi, then my path difference will be how much? Lambda by 2. And if it is lambda by 2, in that case, since, can you see, this n equals to 1, therefore this will be my first order. Or I will say, so I can write first order dark fringe. Okay, see, this is your interference pattern. In this interference pattern, the bright maxima and your dark fringe minima both have the same fringe width beta, and we have already derived the relation, and we have shown that your bright fringe and your dark fringe are of same width. So you can see this one is also beta as well as this one is also beta. Now here, can you see, we are considering what kind of wave? Cos wave. So we are considering the minus 1 value, that means the lowest value. So can you see at this point? At this point, it is at the lowest value. Fine. And what is the order? N equals to 1. At n equals to 1, okay, at n equals to 1, you are getting the lowest value. And at this point, you are getting the first order dark fringe. That's why it's written here, first dark fringe. Fine. But whereas in case of your bright fringes, you started from n equals to 0. If you start from n equals to 0, that means, can you see this first one? This, at this point you had the maxima, and this one corresponds to your n equals to 0, which is known as your central bright fringe. This is known as your central bright fringe. And here, then you have the corresponding n equals to 1. So the next successive one, can you see this one? This is your first bright fringe. Fine. So the one which is n equals to 0 is central bright fringe, and n equals to 1 is your first bright fringe. But in case of your dark fringes or your destructive interference, since there is no n equals to 0, therefore we don't get a central dark fringe. Fine. So we start from first dark fringe. Fine. And this is the distance from the center. Okay, to find out the distance, I have already derived this relation equation. To find out the distance, what was the relation? You can go back to your lesson number 31. In lesson number 31, I have derived the equation for the position, where x equals to n lambda d by d, and this corresponds for the bright fringe. Similarly, for the dark fringes, you can use this relation, twice of n minus 1 lambda by 2 lambda d by t. Fine. So in my figure, can you see d lambda by 2d? This corresponds to the which position? Lambda d by 2d. Can you see? This is lambda d by 2d. This corresponds to your first dark fringe. Okay, this is your first dark fringe, lambda d by small d. Lambda d by small d. This corresponds to the position of the first dark fringe. Fine. Now you can repeat this one thoroughly. Again, substitute the next order, n equals to 2. If n is equals to 2, then my phi will be 2 2s are 4 minus 1, 3 pi. If my phase difference is 3 pi, what will be the part difference? Part difference will also be thrice of lambda by 2. So at when the part difference is 3 lambda by 2, the position and this one will corresponds to which kind of dark fringe? This will corresponds to second order dark fringe. And the position of the second order dark fringe is 3 times of lambda d by 2d. Fine. So in this manner, you can get your first order, second order, third order, fourth order dark fringes, so on. Fine. So from your board exams point of view, only this two is important. Okay, and how you are getting this one? So these two equation. Fine, these two equations are known as your conditions for your destructive interference. So from your board's perspective, hence the condition of the destructive interference will be phi equal, the phase difference should be how much? Odd multiple of pi, and the part difference should be odd multiple of lambda by 2. Fine. So we have derived the condition for your constructive interference, and we have derived your condition for your destructive interference. Fine.